Hey guys, in this problem I'm going to discuss how to do a two sample Z interval for proportions. So, can leaving the hospital early after having surgery help decrease the infection rate of a person? 19 out of 1,005 people who left the hospital less than a week after having back surgery had an infection, and 14 out of 500 people who left the hospital after a week, a week or after, had an infection. So there's two people here. There's a group of people who left before a week, and there's a group of people who left a week or after. Calculate a 95% confidence interval for the difference in the proportion of people. This part here will help you write your conclusion. Remember that all confidence intervals, there's going to be three steps. So it's going to be conditions, formula, and then interpretation. So what I did first was I extracted the data. 19 out of 1,005 had an infection when they left the hospital. 14 out of 500 had an infection when they stayed in the hospital. Just FYI that this number is actually higher than this number. Okay, so 14 out of 500 is higher than 19 out of 1,005. So you should leave the hospital early. These are the complements. You get this by doing 1,005 minus 19, and this by doing 500 minus 14. So these are your N1s and N2s. Your conditions. I'm sorry that I didn't write this, but I'm going to assume the stem of the problem states that both samples were chosen randomly and that they are independent. That's actually important because you don't want any of these 1,005 to be the same people that are in the 500. So you got to make sure that they have nothing to do with one another. So I'm assuming the problem stated that they're both random. Then your second condition is you have to check to make sure that all four of them are greater than 10, not greater than 30. 30 is only for the central limit theorem. So I did 1,005 for this one times 19 over 1,005. So that's 19. We do 1,005 times 986 over 1,005. So that's this guy. We did 500 times 14 over 500, so that's that guy. And the same thing to get 486. You have to say why you did this. So the reason why we did this was since all the values are greater than or equal to 10, we can assume the distribution is approximately normal. That's very, very useful because you can't do a confidence interval unless we have some sort of reason that it's approximately normal or normal. So that's part one. Part one is those two conditions, randomization and that they're both bigger than 10. Step two is going to be the formula. You're going to say statistic plus or minus critical value times the standard deviation of the statistic. You're then going to decide if it's a one sample or a two sample. Since it's two sample, you're going to go down to either the difference in sample mean or the difference in sample proportion. The difference in sample proportion is this guy. Plus or minus, we know it's a 95% confidence interval, so that's 1.96. I should have probably put a z here. Times the standard deviation of the sampling distribution, or the standard deviation of the statistic. It's going to say on your formula sheet P1 times 1 minus P1 plus P2 times 1 minus P2. That's the same thing as what we call Q. So I put this here. You have to set up the mechanics. So 19 out of 1,005, 14 out of 500, plus or minus 1.96, and then we put this here. Remember that P's and Q's are all fractions or decimals. Put this here, then we're going to use our calculator. How do we get there? Well, we know that our calculator for confidence interval is the number 7 or after. So you press stat, okay? Then you go to test. Then you go to 2-prop Z interval. X must be a whole number, N must be a whole number. Calculate, you get that. What you notice here is that you have a negative number and a positive number. That's actually really important. So let's use this for our interpretation. Based on these samples, we are 95% confident that the true difference in proportion of people who had an infection when leaving the hospital less than a week and a week or more is between negative 0.0258 and 0.0076. So that is basically saying, hey, there's a little bit less, there's a little bit more. It just depends. So anytime we do a problem that's 2 sample confidence interval, then what we're going to do is we're going to write a second statement. That second statement says, since the interval contains 0, we don't have evidence of a difference in the proportion. I should have written in the proportion of people who are infected if they left the hospital early or if they stayed longer. At the alpha equals 0.05, because this is a 95% confidence interval. Typically, they ask this as a part B or in their own part. So, or as a separate. So this is our conclusion, and then you should take a look and say, oh, negative and positive means it contains a 0, and so we do not have evidence to suggest there's a difference. If it was all positive or if it was all negative, then we do have evidence. So I hope that was helpful. Take your time. I know I said it really fast, but take your time and go through it. First watch it, then you can do it yourself or vice versa. Okay, thank you.